Let us see how you can declare arrays. To declare an array, we first have to write int a of 6. What the statement says is that a is an array which is capable of holding 6 integer values. Once again, a is an array which is capable of holding 6 integer values. And I can initialize the array as follows: equals curly brace 15, 82, comma 46, comma 31, comma 2, comma 92, semicolon. So this is one way of declaring arrays. Now remember, if you want to declare an array containing floating point values, you have to write float b of 3 equals 3.14, 6.023, negative 10.2. This is just an example. You can store more number of values in the array. That's not a problem. Just make sure that you change the dimension. And if you want to store characters in your array, you write character C of 3 equals dollar uppercase A 6. Remember, arrays are only capable of holding values of the same type, which means you can have an array of integers or an array of floats or an array of characters, but not a mix. This is one way of declaring arrays. The second way of declaring arrays is int a of 6 semicolon. This is just declare, and if you take this is declare and initialize. So as soon as you declare the array, it's going to create the structure here. So that's 6 elements. The array can store 6 elements: index 0, index 1, index 2, 3, 4, and 5. Now I can manually write values into the array. To access the first location, I can write a of 0 equals 15. So as soon as you make this declaration, this is going to get filled with 15. A of 1 equals 82. So this location gets filled with 82. A of 2 equals 46. So 46 is written here. A of 3 equals 31. 31 is written here. A of 4 equals to 2, written here. And finally, A of 5 equals 92. So 92 is written here. Now for supposing, let's say I want to modify this one to the number 31 or 32. How would I do that? I can simply write a statement saying a of 1 equals 32. So 82 is now overwritten with 32. What if I want to add 5 to this element here, which means that this array location should contain 7. I can simply write a of 4 equals a of 4 plus 5. So whatever content is there in a of 4, 5 is added to it, and the result is stored back in the same location. So this is how I can declare and initialize and manipulate values in the array. In the third method, we can use scanf to read values into the array. So you can write int I, int a of 6, and I want to read 6 values into the array. Now remember, here I can start using loops because I know that my index of the array is going to go from 0 to 5 because it has 6 elements. So going by this, we can write 0, 1, 2, 3, 4, and 5. I can write for I equals 0, I less than or equals to 5, I plus plus, scanf, percentile d, comma, ampersand a of I. So this is another way in which you can read values into the array. As you can see, methods 1, 2, and 3 are very tedious because the user has to write all the values. Right? See, here you have to write this manually. Here you have to write this one manually. And here you have to read them manually as well. It's not an easy process, especially when you have larger arrays. For your lab assignments, we are going to write a random number generator which will automatically put values into the array within a specified range by the user. So assuming you have specified the range to be between random values to be between x and y, you can write a code which will fill your arrays with values between x and y. So this alleviates the problem of having the user to write the values manually. Similar to reading values into the array, you can also display the array elements. So assuming if you have an array with values index 0 through 6 and values, let's say 10, 20, 30, 20, 10, 30, 0, you can display it using a loop. So for I equals 0, I less than or equals to 6, I plus plus. Here it's an array of 7 elements. You can say printf percentile d, comma, a of I, assuming that this array is named as a. So using these concepts, we can initialize, read values into the array, and display the array contents.